Hey, hi, y'all. This is Sarang here. My name is Sarang, and I'm a baby data scientist. I'm trying to learn data science, and I just wanted to create a personal project. Um, and very interestingly, the State Bank of India released some data on electoral bonds. So I thought it would be interesting to consume this data and do some data science on it. Um, so that's why I'm making this video. Um, I'm definitely expecting the data to be not in very machine readable format, very easy to read. So it would be interesting what all data cleaning or data wrangling will need to do on this data. And this video, I'll in this video, I'll just do the data cleaning and wrangling activities and create, these data sets which can be used in good data visualization. So maybe I'll create another video in which I'm using this clean data sets for interesting visualizations, and we'll see what insight that visualizations can give. But even then, while we are cleaning this data, I'm expecting to have some interesting insights. So let's see what we'll discover, right? I mean, the news are out there, but from a data science perspective, what could be interesting? So I'm interested in that more. So let's see. So yes, I have opened this PDF file that the Election Commission uh, has uploaded. Uh, and it's quite an interesting file. It's a PDF file for some reason. It could be a very raw data, but they are, or it could be an HTML report or something. But nonetheless, we'll have to read this PDF file, and it has three columns. The date format is interesting, and the denomination number is typically Indian format in lakhs and crores, thousand lakhs and crores. So definitely this will need some work upon. And I did some basic research and found that one of the ways we can um, read a PDF in Python is by using the Tabula library. So this library is a wrapper for Tabula Java library, and it requires Java 8 plus and Python 3.8 plus. So I have installed the latest Java version. It's 21 plus, and I'm going to install Tabula as well. So let's start. Here I'm checking the Java version. I'm installing the Tabula library here. It gives a message. We can ignore that. And I'm importing Tabula now in my environment. So here we are going to read this PDF. I've saved it on my D drive in a folder called EB, and this is the name of the file. I've kept the name as it is, and we are going to read this PDF file here. I'm reading all pages because the read PDF function Tabula by default reads only the first page. Um, so also I've given the header option as none. So this to ensure that the top column is not set as the column. The top columns are not set as the column names by default. So what it will do is it will make the actual column names as a row in whatever data set it's going to create. So as you can see, the actual column names are only on the first page of this PDF. If you scroll down the next page, there are no column names here. So since it reads page by page, what it will do is on the next page when it's reading this table, it will create the first row as the column name, and as many pages are there, we'll lose that many rows from the actual data, and instead it will be a column name. So we'll lose almost 336 actual data rows, and only the first data set will have the correct column names. So by making the header option none, I'm reading all the rows as um, actual data. So I'm expecting that the this top row will also be part of the data set. That should be fine as long as we can read all the rows. And in the end, we can do this cleaning and we can remove this row and set the column names, etc. So right from the start, we can see the data was not created machine readable, and we will keep encountering these issues, right? Um, I'm just printing the top three rows of these data sets created. So as you can see here, it is creating a list of 337 items in this list, and each list is a data frame. So if I print the first three rows of the first data frame, it shows that the column names are in the first row. And if I print the first few rows of the second data frame, it's all data. So this is as per our expectation now. But very interestingly, you can see there are four columns here, there are three columns here, and uh, what I'm doing here is actually I'm concatenating all these data frames in this list into one single data frame. And when I do a describe, what it has done is it has created five columns. So definitely in one of the data frames out of these 337 data frames in this list, at least one data frame had actually five columns. So these two first two we can see it has four columns each, but definitely one of the data frames must be having five columns. So let's see what data issues it has. I can see the count here of the first column as 18872, which is the purchase date of purchase. That column should have all data with not being null. So this count is the actual count. So actually it is 18871 plus the name of column row. And subsequent columns, the number of rows are less than that. So here it's 18870, it's 16963, 1905, 167, etc. Um, so the date column being correct, definitely the name of the purchaser column, even the first row we can see the first this column itself there is no data, and the purchaser name was shifted to the third column. Whereas we can see here there are only one, two, three columns, and if you just move your cursor, you'll see there is suddenly something that is getting selected, some tab, some table, I'm not sure why or what it is, and that is actually creating this cell to be as null or NaN, and then the purchaser name is shifted to a third column. And I'm guessing similarly there are tabs or like um, invisible table or something, cells being inserted, maybe uh, due to some technical issue. We don't know that. Because of which the names of purchaser is getting split into two or three cells, and it's getting shifted further towards the right. I'm guessing or attributing it to tabs being inserted in purchaser name, or there could be some hidden table somewhere. We don't know, or hidden cell. If you have more ideas around this, please comment. It would be really helpful for me to understand. If I would describe, so here we've basically got a one whole data frame of by concatenating these 337 data frames in this list. And if I do a describe of this data frame, we've got some values here which will help us to understand what this data frame has. And I first thing I did, I downloaded this data frame into a CSV to visually see what how does this data in the first place looks like. So this is the first download of the CSV. Um, as you can see, the purchaser name has already shifted one cell. And if I just scroll down, you can immediately see here that, for example, the LTD part has shifted to a different cell here, which has further shifted the denomination. Or we can see further more examples, I hope. Yes, we saw something here. Uh, Here, just for no reason, the denomination has shifted one cell, maybe just tab. So we can see all these examples uh, where the cells have shifted by one position or two, right? So let's see how we can clean this data and bring it in a proper format. Um, let's run this notebook up till this point because I haven't run it again. So yeah, so I've reran the notebook up until this point. Mm, and I'm just trying to verify what are the indexes, how to play with the indexes here. So as you can see, uh, the second column, first row, so 20 is purchaser name here. Second column, uh, I'm sorry, here, the first download of data, right? So I want to shift this towards left. So that's what I'm doing here in this box. I'm shifting the purchaser name to the second column and the denomination to the third column. And whatever it is in the last column, first row, I'm shifting it to the third. So I'm guessing it's NAN. So yeah, it's NAN. And if I do a quick review of the rearranged first column, you can see the date of purchase, purchaser name, denomination has been aligned correctly, and the last two columns are NAN. I mean, the first row of last two columns is NAN. That's fine. We'll continue doing cleaning. We'll continue cleaning the data. So now here is the real deal, right? Um, I've imported the math library to, to check alphanumeric or is the column, is the cell NaN type. And I'm basically going to iterate through this data frame. and start the cleaning of data, rearranging the cells in their proper columns, right? So as you can see here, the first row, we don't want to do any change. So what I've done is I've continued the loop for the first row, right? So if I equals to 0, I'm just continuing. So now the control has moved to the second row. Uh, so ignore this internal for loop for one moment. I'll explain why I've included that. Okay. So in this condition, if condition, what I'm doing is I'm checking um, uh, if the item or the object in this column, the column with index 2 or the third column, and the corresponding row, right? Is it a string type? If yes, and if the first character of this string is a alphabet. So why I'm checking this is to exclude all those values in this column which start with a number. So may it be 1 lakh, 1 crore, whatever it is. So if it is not an alphabet and if it's a number, I'm assuming that it's a number in this column. So I am ignoring that with this. So only if there are any alphabetical any strings in this column which start with an alphabet, in that case, I'm shifting it towards left. And by shifting, I mean I am adding it at the end of this string, right? So here I'm concatenating the string in this column and that particular row with the value in this column. Uh, we'll download the CSV further and see whether it has done it correctly. Having done that, I am again shifting the value in this column to this column. So column with index 3 to column with index 2, and then the value in column index 4 to column index 3. So I am slowly shifting the values towards left. Having done that, I'm again checking. So now I have shifted all the strings that start with an alphabet, right? So now I'm checking uh, the um, nan values, right? So first I'm checking if the value in this cell is nan by using this if condition, and I'm using the math library. If it's a nan, I'm again shifting the values from this column index 3 to column index 2 and column index 4 to column index 3 here, right? So there's one level of uh, shifting to left completed, and I'm running this piece of code twice again for this same index in this for loop so that I'm shifting two levels towards left because there are two additional columns. So both these operations I'm doing twice for the same row, just in case whichever gets applicable. So after this whole for loop has been executed, I'm assuming that all the shifting and all the concatenating of strings has been completed. And then finally, I am uh, checking in the denomination column, the column index 2, if it's a string and uh, replacing the columns, the commas, I'm sorry, with nothing so that it creates a straight number and converting it to an integer type. Okay. So now if we describe this, uh, you can see that the first three columns have correct number of rows as expected, right? And there are same still values in columns 3 and 4 in some of the rows, but we are not concerned with it now because all the values have been shifted 2 levels to column 1 and 2 as required. So if there was a alphabetical string in column 2, it has been concatenated and added in this column index 1 with the existing string. And if there was a number in column 3 or column 4, it was shifted left by 1 or 2 levels in column 2, which is the denomination column, right? So if we describe it again, we can see some consistency. And even though it's not showing all rows, that's why we can't see whichever rows are having values in column index 3 or 4. Now, we can re-download a CSV of this data set and have a quick visual. So let us do that. So I've downloaded the CSV in this cell. And when I open this CSV, and I do a quick scroll down, I can see that the first three columns are more consistent now. I barely see any inconsistencies. The third column has proper numbers, but I should expect column 3 and 4 to have values. Let's see if we see them in a quick scroll. Yes, I just saw some values in column 3 and 4, but we are not really concerned with those values now because they have been copied correctly. And we are going to drop columns, the last two columns basically. So in this piece of code, I'm dropping column 3, right? Right. And if I do a quick review, I can see column 3 has been dropped. The last column is still visible. And I'm rerunning the same code to drop the final column. Now, with this piece of code, what I'm doing is I'm setting the column names of this data set same as whatever values are present in the first row. So ILOC 0 gives the values in first row, and I'm setting those same values as the column names, right? I'm going to set that. Now both the first row and the column names are same. Now with this piece of code, I'll drop the first row as well. So let's execute that. And in this piece of code, what I'm doing is I'm setting the type of this first column, which is a date of purchase, as a date time instance or date time data type. Why I'm doing that is so that I can do sorting correctly. I don't want to do string sort on this. I definitely want to do sorting as per the date. So that's why I'm setting that. Let's do that. Oh, there's an error. Let me check it. We have resolved that error. Maybe it was due to not running the whole notebook correctly. I've rerun the whole notebook again and the error was resolved. So here, if I review this data set, you can see it's a data frame, and upon describing it, I can see the date of purchase is a date time variable. So yeah, all the values are also not null in all the three columns, and the date of purchase is a date type variable. And I've also downloaded uh, the CSV. So let's quickly have a quick view on it. So I can see that there are just three columns. There are no columns here. The numbers are looking good. Um, the data is looking good. If I quickly scroll, it looks all good. Um, so I'm guessing that this data is much more readable at this point. It looks quite clean. Um, I don't see any discrepancies. Now I'm just trying to play with the data a little. What I'm trying to do is I'm trying to create a data set um, uh, to remove any duplicates and also to aggregate the denomination uh, uh, grouping by the date of purchase and the purchaser name so that we get a more clearer idea. And I'm also sorting the resultant data set in a way. So if you see the sorted data set, I've aggregated the denomination. You can see the number of rows have drastically reduced. So there were multiple bonds being purchased on the same date by the same purchaser. So we have aggregated them so that we have much more usable data, right? Uh, let me download this new resultant data set. Uh, and this is the denomination aggregated sorted data set. You can see uh, the purchaser name is now clearly understood and who has purchased uh, how much bonds aggregated is more easily understood in this data set. So I'm pretty happy with this. I'll aggregate it further and remove the date, and we'll get a final, a singular value of which purchaser has collectively purchased how much of how many bonds collectively, right? The actual value of bonds aggregated. So I'm doing that in this separate data frame that which says no date in it. And I've created it. And if I run the top 25 values, I was just going through it quickly and I saw a very interesting observation. So as it is known in the news now by now that this Future Gaming Hotels is the top purchaser of the electoral bonds. But if you scroll down, you can see it repeated. So here it is Future Gaming and Hotel Services ER, whereas the 21st top is Future Gaming and Hotel Services Private Limited, and the denomination is pretty comparable, I would say. So I'm guessing whoever was analyzing it for the news channels or the YouTube news channels, they must have observed it by now, but maybe if they have not, then uh, this is a very interesting piece of information. And I think these two are actually the same um, purchasers, and whoever created this data has due to a technical issue or deliberately, I am not sure about that, created these two different names. But these two are clearly the same purchaser. So if you aggregate these two values, it's really high, right? Um, yeah, I think we have a very good data set. We have two different data sets now, which we can use for visualization, and I'll create another video visualizing this data and see what more insights we can get. So thanks for being patient with me, and let's see what comes out in the next video. Bye.